Okay, you ready? Okay, so here we go. An asymmetrical roof. What does asymmetrical mean? The opposite of symmetrical, right? If something is symmetrical, you can cut it in half. So let's put an arrow here. Can't be split exactly down the middle. Okay? That's what that means. An asymmetrical roof cannot be split exactly down the middle. It has sections that are 18 feet and 14 feet long. How wide is the building? The roof has a rise of 6, I guess that should also be added. How wide is the building? So it's basically asking you BD, right? If you look at the shed down here, right, from point B to D, if we knew that whole distance across, then we're good to go. Question, can you use sine law, cosine law? Yes, you can. I won't always do that. In this case, let me see what I've got here. I will rather cut this thing, cut it up, and then work within each of the smaller triangles. Okay, so can you put a little 1 here and a little 2 here? Okay. So you've got 1 and 2. And can I use the Pythagorean theorem to accomplish this task? Look at both triangles have this 6 that they share. So two sides, and it's a 90-degree, right? So I'm going to use for both of these, I'm going to just use Pythagorean theorem. So why don't we do the work right here? Cut it up like this. 14, 6. Let's call this x. And on the other side, we're going to do the same. But we're going to call that y here. This is still 6, and this is 18. So let's, y is a leg, right? X is also a leg, so you need to just figure that out, right? Y is square root of, take the longest side, which is the hypotenuse, subtract the other leg from it. And grab your calculators to follow along, right? I don't know, like I would not want to lose marks just because my calculator is acting up on me the day of the test, right? So that's 288. Root of 288. If my answer is 288, it just would be so out of whack, right? It just wouldn't make sense. So that's another indicator. Hey, take the root. So 16.97. I told you to use how many decimals as you're working? 4. Yeah, so why don't we do that? 9706. And then I'm going to go over to the other side. X is also the leg there. So just square root and take the hypotenuse, subtract the other, and just figure it out. So that's a root of 160. That's 12.6491. Hey, if you want to be really fancy, right? If you want to really, you can just leave these in their roots. And then just add root of 288 plus root of 160. And then it's going to be the most accurate. So now I want to go underline this, underline that, like this. And we're going to go up there and answer A. We're going to go up to where the worded part is. So write down A, add X plus Y, right? So we're going to go 169706 plus 12.6491. And that is 29.62, and we are in feet, right? So I hope you can tell. If you have highlighters, it doesn't hurt, right? That's how I accomplished that task. B. This is the one you're most likely not going to like. Classify ABC triangle. You see that symbol? Sorry, let's make sure. It's triangle, 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 not angle, right? So triangle ABC, which one would that be? Well, I'll just follow it. A, B, and C. So it's this one right here. Let's do that. Follow me. So this is triangle ABC. This is triangle, according to the top there, ACD, right? ACD. So this would be ACD. Just make sure we have the letters written in there so you know that this is that. And what's triangle ABD? ABD. So it's asking for the whole thing, the whole roof. What kind of triangle is that? So let's do that here, down here. It's important to know what we're talking about. So A, B, D. Write down the side lengths. This is 18. This is 14. And the length, this we just figured out is 2962. Okay. Are any of the triangles we just worked with either equilateral or isosceles? Are any of our triangles have any two sides that are the same? So all of them are scalene, right? They must be related. They're all the same. They all have the same last name. So let's do that here. Let's do that here. Let's do that here. They're all scalene. So there we go. What about their angles? When it comes to their angles, what do they all have in common? They're all right. Well, the top, these two, right? These two are right. Okay, right, right. So what about that last one? Would you just guess? Or is there a way to find out for sure? This is a side, side, side. We can figure out the longest side is A, so there's a big chance that that's obtuse, right? So we're going to do this. I allow you to do this. Watch. Cos A, the side that's across from it, squared. 18 squared plus 14 squared. Watch this. We're not even going to care about the rest. What am I going to check? If I want to check to see if this is negative. That's exactly what I'm going to do. I don't want to actually find out the exact. So 18 squared plus 14 squared minus 29.62 squared. What do you think? It's negative. Negative 357,344. Do you have a highlighter? This is the highlight of today's lesson. Right there. That tells me that this is obtuse. That tells me that that angle is obtuse. You are allowed, I allow you to do that. You don't have to actually solve for that angle. We just want to do a quick check and see if the top is negative. Case closed. We know that whatever cosine of A, whatever inverse cos spits back is going to be greater than 90, right? Guaranteed. So it's an obtuse. Hey, why don't we highlight the negative right there with that? There we know it's obtuse. stands out. So you got to be creative. That's why I do trig before I teach this. I teach trig before I teach this, so you have that tool available. Okay. All right, moving on, guys. So I mixed up some math with classifying, all of that stuff. You know what? Can you do this in your notes? Just break this up like that. Right? Kind of just make sure you know that, right? We dealt with each section individually. What's that? That's right. Okay. I'm gonna skip this one. I think this might be tomorrow's AC. Maybe. We'll see. I just gave it away, right? That's okay. Tomorrow I'm going to start quadrilaterals. So, how much time? Oh, not much. So go to 185. 185. There's a blank slot there. I'm going to use that tomorrow. So just go to the bridge, right? That looks like the Redwood Bridge or the Arlington Bridge or Louise Bridge. Yeah, any old bridge basically in Winnipeg. Try to think of how to solve this. It's actually pretty cool. It was an old exam question that kind of based their question off of something like this. Look at the markings. Look at the markings and stuff and try to answer how long is the bridge, all of those things, and then classifying and so forth. And so if you're stuck, guys, ask me or keep working on something else. If you didn't do yesterday's stuff, you take your workbook and you work through pages 3 and 5 in this workbook. You name it. You decide what you want to do. Go.